State Newton's law, second law of motion. Again, you can see that the kinematic questions are not completely independent of other topics. So some of the topics always show up. State Newton's second law. Net force acting on an object is directly proportional to rate of change of momentum. Or for an object which is free to move, net force is directly proportional to rate of change of momentum. A delivery company suggests using a remote control aircraft to drop a parcel into garden of a customer. When the aircraft is vertically above the point P on the ground, it releases a parcel with a velocity that is horizontal and magnitude of 5.4 meters per second. The path of the parcel is shown like this. The parcel takes a time of 0.81 seconds after it's released to reach the point Q on the horizontal ground. Assume a resistance is negligible, and this is important. Okay. Now, use figure to draw an arrow at point X to show the direction of the acceleration of the parcel. Remember, the acceleration is always along the net force acting on the object. Over here, if a resistance is ignored, there is no forward force, no backward force, no upward force on the object, because we are considering that there is no upthrust as well. So the only force acting is gravity, and that is acting downward. And acceleration is always along the direction of the net force acting on the object. In this case, the net force is downward, so acceleration will always be. Acceleration is always along the direction of net force. That is very important for you to understand. So we just got 1 mark. Determine the height edge of the parcel above the ground when it is released. Okay, for that, we only need this piece of information that it took 0.81 second to land on the ground. So here's the data. We know that the time taken is 0.81 seconds. Initial velocity is 0. You might say, no, it is 5.4 meter per second as said by the examiner over here. Remember, this 5.4 meters per second is the horizontal velocity. When this object was released, it was not traveling any vertical distance at all. So its vertical velocity was 0. So its vertical velocity starts increasing at this point. So initial vertical velocity will be taken as 0. Acceleration for coming down is 9.8 meters per second square. And somebody is asking you for distance travel, which is equal to height. Now, how much distance it has traveled vertically downward? So, which formula you think should apply over here? We have a formula, height equals to half AT squared for something which is dropped from rest. So it is 1 over 2 into 9.8 into 0.81 square. Point 5 multiplied by 9.8 multiplied by 0.81 square. So it is 3.21 meters or 3.2 meters. So calculate the horizontal distance d between point P and Q. Now we need this horizontal distance d. Remember, Object is going without air resistance, so there will be no effect on the horizontal velocity. Listen, if there is no air resistance, then there is nothing which is slowing the object down, and there is no reason for the object to speed up because there is no thrust provided to the object. So object will neither speed up nor slow down, so we can use the constant speed formula for this one. What is the constant speed formula? Constant speed formula is distance equals to speed multiplied by time. And as we know that the speed is 5.4 meters per second and time it took to strike the ground was 0.81 seconds. So all we have to do is multiply 5.4, 2.81 and get 4.4 meter, 4.37. So the final answer can be presented as 4.4 meter. So this is how we solve this one. Now, another parcel is accidentally released from the rest by a different aircraft when it is hovering at a great height above the ground. Air resistance is now significant. So we cannot now ignore air resistance. Okay? So air resistance is not negligible. On figure, draw an arrow to show the direction of the forces acting on the parcel as it falls vertically downward. Label each force with the name of the force. Object is having a velocity downwards. So these are the forces acting. The force I made downward is weight, and the upward force is here. Remember, air resistance or drag force always acts opposite to the direction of motion of an object. Object is coming down, and this is how we can get these easy, sweet 2 marks. By considering the force acting on the parcel state and explain the variation, if any, of the acceleration of the parcel as it moves downward before it reaches the constant terminal speed. Now, remember, object reaches the terminal speed. That means the acceleration has to become zero and the object is supposed to fall down with a constant speed. How does that happen? Now, this is the whole story. Initially, only force acting will be weight. So, acceleration will be maximum at 9.8 meter per second square downwards. As object moves, air resistance develops. Air resistance increases with speed. As air resistance and weight are opposite, net force decreases, so does the acceleration. When air resistance becomes equal to weight, net force is zero, so is the acceleration. And object falls with the terminal velocity. Okay, so this is the story of object achieving terminal velocity. In the beginning, as object is dropped from rest, there is no movement, no air resistance, only force acting is weight. And with the passage of time, as object starts to move, speed develops, so does the air resistance, and net force starts to decrease. And finally, when air resistance and weight become equal to one another, there will be no net force, no acceleration. Object will fall with constant speed until it hits the ground or something else happens. Describe the energy conversion that occur when the parcel is falling through air at constant speed. Gravitational potential energy is converted to work done against air resistance. So all the energy that has been lost by the falling object, the gravitational potential energy that is lost by the falling object, has converted to work done against air resistance. Now, what basically a student wants to say is loss of gravitational potential energy is gain of kinetic energy. But hold your horses over here. This is not a gain of kinetic energy case because object is falling with a constant speed. It means gravitational potential energy is decreasing, but kinetic energy is not increasing. That means gravitational potential energy is not becoming a reason of kinetic energy to increase. So for sure, gravitational potential energy in this case is not becoming kinetic energy, it is becoming something else. Look for it. What it is doing. Object is falling through the air. So it will be fighting with the air molecules on the way. So air resistance uh, is causing an opposition force or opposing force, and object has to make its way through the air. So it will definitely be pushing away the air molecules, so that energy is being used to